Hello everyone, my name is Suraj and I'm a data engineer with over 3 years of experience in the same field. Whether you are a data engineer, a data analyst, or a student, a beginner just starting out with data, this channel is all for you. And in today's video, we will be discussing more about SQL, RDBMS, and advanced database concept that is purely required for data engineering. So without delaying, let's get into the video and see what are all topics are required for this SQL and RDBMS and advanced database concepts for data engineering. First off, let's talk about why SQL and RDBMS are so important for data engineers. Whether I was working with my previous organization Wipro and now with Haridas, SQL has been one of the foundations for working with data. SQL allows you to interact with relational databases, which is widely used even now in a number of organizations to store and manipulate the structured data. As a data engineer, you'll be often required to build data pipelines that can fetch data from varied sources, then again transform them as per the business requirements, and then finally load them on relational databases or data warehouses. So without SQL, performing these tasks could be quite challenging as compared to when we use SQL for performing these tasks. SQL is widely used to store, manipulate, and retrieve the data as per the business requirement and in a more precise way. Now, relational databases allows you to store data in the form of table, enforce integrity, and ensure that data is reliable and consistent throughout the period of time it is being used. Now, let's break some core SQL concepts that you need for data engineering. The first thing is DDL, data definition language. DDL is all about defining and managing the structured data for your database. This includes commands like create, alter, drop, which you will use to create tables, then again modify their structure or remove them when no longer needed. And as a data engineer, you will need to know how to create efficient database schemas, set up primary keys, then again how to define foreign keys and enforce constraints to maintain data integrity. Right now, for example, when designing a customer database, you might use DDL commands to define the structure of the customer table and ensure that every customer has a unique ID. Next is DML, data manipulation language, which includes commands like insert, update, delete, and select. This is where the real magic happens in terms of moving and querying data. DML allows you to add data to database, modify it, and retrieve it based on complex queries. You'll often write SQL queries to pull specific data for reports, analyze trends, or for feeding machine learning models. Now, understanding how to craft efficient queries using select and filter data using where condition is fundamental for ETL, right? Which is, must required for data engineering. Next is joins and subqueries. In real world scenario, you might see the data is not stored in just one table. In any of the use cases, you will see the data is stored in number of tables, and you'll have to combine these different tables to form some insights, or let's say get some data which can be used by other stakeholders. So this can be only done using joins. Unless you are aware of join, you'll not be able to combine the different tables and get the required data. Subqueries are also important when you need to break down complex queries into smaller parts, allowing for more flexible and powerful queries. Fourth is indexes and views. As your database grows, performance and speed is the major concern which the companies think of, right? So that's where indexes comes in picture. Think of a database that has millions of data or millions of rows of data, and you want to fetch some specific row or specific data. Then using indexes, you do not need to go through the entire data or scan the entire data. That specific data or specific row can be fetched immediately using indexes. Now coming to views, views allows you to create virtual tables based on a result set by a query. They are helpful for simplifying complex queries and making them reusable across your organization or maybe across the teams with whom you are working in. Now coming to advanced RDBMS concepts that are required in data engineering, and the first thing is normalization and denormalization. In relational databases, normalization is the process of structuring your data to reduce redundancy and improve data integrity. This involves breaking down large tables into smaller related tables. For example, you wouldn't want to store the customer data in every order, right? They should be stored in separate tables and linked by a foreign key. However, in data engineering, sometimes you'll have to denormalize data, meaning that you intentionally add redundancy for the sake of speeding up the read operations, especially in data warehouses. The key is knowing when to use normalization and when to use denormalization, so that the task, or let's say the agenda you want, can be met more efficiently. Second thing is transactions and ACID properties. When working with database, you want to ensure that operations are reliable and consistent. This is where transactions and ACID properties comes into picture. A transaction is a series of operations that should either be completed successfully or rolled back if something goes wrong. The ACID properties like atomicity, consistency, isolation, and durability ensure that transactions are processed reliably. For instance, if you are transferring money between two accounts, either both accounts should be updated or none at all, right? I mean, if you are updating one account and other account is not updated, that means there is some issue with the data, or let's say the transaction, right? So both the data ends can be updated simultaneously, or none of them has to be updated. Next is stored procedures and triggers. As a data engineer, you'll often write stored procedures, which are pre-compiled SQL code that you can reuse to perform specific tasks within the databases. This is great for automating repetitive tasks like data transformation or validation. Triggers, on the other hand, are automated responses to change in the databases. I mean, if there is any change, the automated triggers will come into picture. For example, if a new row is inserted into a table, a trigger can automatically execute a store procedure to update the related table, right? These concepts help you to automate workflows within the database itself, reducing the need for external scripts, or let's say external involvement of any of the developers. Now, next thing is database partitioning. When working with large data sets, query performance can start to suffer, right? So partitioning comes into picture here, allowing you to split a large database into smaller ones, and that can be more manageable pieces based on a key like date or reason. This involves query performance by allowing the database to only scan a subset of the data rather than the entire table. It's a critical technique for working with large data bases, especially in data engineering roles where performance is crucial. I mean, what we do is we'll read a huge data set, then break them into different partitions based on maybe weeks or date or reason. Let's say we have read our data for different reasons, then the partitions can be created based on reasons. Or let's say if you are reading data on daily basis, then the partitions can be created based on date. And whenever any query has to be performed on any of the specific dates, then only that particular data is read instead of reading the entire date's data. So that wraps the key concepts of RDBMS, SQL, and advanced RDBMS concepts that are required for data engineering. If you found this video helpful and enjoyed the video, then do hit the like, share, and subscribe button for more content like this. And also in comment section, let me know if you have any questions or any suggestions for future videos. Thank you.